If I divide by 7, I'm going to get 1. So whenever 0 is the exponent, then that means that the result is 1. So any base to the 0 power is 1. We also looked at negative exponents. And so all that we do there is we flip the fraction. So what does that mean? Again, let's say I have 5 to the negative 2 power. Well, the first thing I would do is I would say, okay, well, what is 5 squared? 5 to the second power, that's 25. Now, 25 I can think of as 25 divided by 1. 25 divided by 1 equals 25. So I haven't changed anything, right? So it's 25 over 1. Now, with the negative exponent, that means that I flip the fraction. So instead of 25 being in the numerator, now it becomes in the denominator, and the 1 moves from the denominator to the numerator. So I go from 25 to 1 over 25. If I have, let's say, 7 to the negative 2 power, well, again, 7 squared, that's 49. And then I go 1 over 49 because I have 49 over 1. Then I flip the fraction. Now, I might have something like 1/4 to the negative 2 power. So there, it actually, so what is 1/4 squared? 1/4 times 1/4 is 1 over 16. But now I'm flipping the fraction because the exponent is negative. So the 16 was in the denominator, but now it's going to become the numerator. So it's not just making it so that there's a 1 in the numerator. If it's a fraction, then the 1 or the numerator will become in the denominator, and 1 will actually end up being in the denominator. So that then we also looked at fractions for exponents. And how does that work? So let's say, for example, that I have something like 16 to the 3/4 power. Well, I look at the denominator in the fraction that's the exponent, and that tells me how many boxes I should draw. So 4 is the denominator, right? I said 16 to the 3/4 power. 4 is the denominator of the fraction in the exponent, so I make 4 boxes. So what number times itself again, and times itself one more time gives me 16? 2, right? 2 times 2 times 2 times 2. So that's 2 to the 4th power. So 2 belongs in that box. So now what do? I've dealt with the 16 to the 1/4 power. I dealt with the 4, the denominator. Now I'm going to forget about the 4 because I've already taken care of it, because that's what the 2 does. 16 to the 1/4 power is 2. Now I have to raise that to the 3rd power. So 2 to the 3rd power is 8, of course. Another example might be 27 to the 2/3 power. Okay, so what is my exponent? It is 2/3. So the denominator in the fraction that's the exponent is 3. So I would draw 3 boxes. What number times itself and times itself again gives me 27? Well, 3 does. 3 times 3 times 3 is 27. So 3 goes in the box. So that means that 27 to the 1/3 power is 3. But now I have to raise the 3, which is the base now, to the power, to the 2nd power, because that's the numerator. So 3 squared is 9. So 27 to the 2/3 power is 9. So we looked at our exponents. Then we kind of reviewed equations and variables and combining like terms and terms. So a variable is a letter or more than one letter, multiple letters that represent some quantity that may change or may be unknown. And a term is a number or a variable with a coefficient. A coefficient is the number in front of a variable. Now, if I have, for example, 5m, there's a 5 in front of the m. What does that mean? It means that I have 5m. So I see 1m, 2m's, 3m's, 4m's, 5m's. So it's 5 times m. So the coefficient is the number that I would multiply by my variable. Now, a monomial is a one-term expression. A binomial has two terms. A trinomial obviously has three terms. Polynomial means that it has more than one term. And what are we doing again with equations? We solve equations. So to solve equations, we have to combine like terms, and we want to isolate the variable. To combine like terms, if I'm looking at a variable, then I want to make sure that the exponent for each similar variable, like for example m, that they're being raised to the same power. I can't add m squared and m to the third power, for example, because they have different exponents. It'd be like adding nickels and dimes. Now, if I change it into cents, then I could. But just as if I am not converting it into pennies, then I can't, right? If I have 3 nickels and 2 dimes, I mean, I can't say, well, I have 5 nimes or 5 dickels or whatever, right? I can't add the dimes and the nickels together like that. I'd have to convert them to be able to be able to add them. So when I'm combining like terms, then I need the variable to have the same exponent. Okay, so what we do with the way that we solve equations is the exact opposite of the order of operations in terms of multiplication and division and addition or subtraction. We look at adding or subtracting first in order to isolate the variable. Then we multiply or divide. Okay, so we want to practice combining like terms just because that's part of our process for isolating the variable. So what if I had m cubed, m to the third power, plus 4m squared plus 2m cubed? Well, the 4m squared is different than the other two terms, so I can't add that term to the others. But m cubed plus 2m cubed, well, that's the same variable raised to the same power, so I can add those together. So that would be, of course, 3m to the third power, and then I would keep my 4m squared. So 3m cubed plus 4m squared. And so we do, that's what we do when we combine like terms. Now we're going to look at practicing evaluating expressions when we're given a value for the variable. Okay, so let's say I had 2x squared plus 6x when x equals 5. So I put 5 in the place of x wherever I see it. So 2 times x squared, so x squared is 25 because 5 squared is 25. So that's the result of squaring x. So I have that, and I have a coefficient of 2. 2 times 25 is 50. Then I have 6x. Now it says plus 6x, but 6x means 6 times x, and I have to, again, I'm following the order of operations because I have an expression, not an equation. So 6 times x comes first, and x we said was 5, so 6 times 5 is 30. So then I add the 50 that I had from 2x squared with the 30 that I obtained from 6x, and I get 80. Now, let's look at some other examples. Okay, what if I had 2x plus 3 inside parentheses minus 3 squared plus 4, and x equals 7. So what do I do first? Whatever is inside the parentheses. So 2x plus 3, well, x is 7, so 2 times 7 is 14, plus 3, that's 17. And that comes first because that's inside the parentheses. So I have 17, says minus 3 squared. So the exponent, remember, please excuse my dear Aunt Sally, exponent comes before subtraction and addition. So 3 squared is 9, so I have 17 minus 9, which is 8, and then I add 4 to the 8, and I get 12. Okay, what if I had 60 divided by 12 times 5 minus 24 plus 1? Well, 60 divided by 12. See, a lot of people get confused with a problem like this because they think,